Hello everyone, welcome to your first SuncatByte, which is a video lecture for CIS 1275 at Central New Mexico Community College, which is Introduction to Computer Programming, and C++ will be the language that we are covering. So first things first, I want to talk about Google and using Google throughout the semester. So it's okay to use Google. Google's a good resource for extra help and videos, etc. But if I do come across good supplemental material, I will get it to you. But please, with that said, as the course will be taught from the book, out of the book. So as we go through the course, I expect you to use what we've learned to that point in the course and not come up with something you found on Google. Google can get you in trouble because there's going to be a lot of advice and things in Google that are way beyond some of the things that we're doing, and it can also confuse you. So please do ask questions, look in the book, go back and look at these lectures over and over. The nice things is they're recorded, so you can look at them multiple times, pause them, just look through things as much as you can, and use the material that we provide for the course. So let's start to talk about programming. Before we talk about programming, we want to talk about hardware versus software, what the difference between the two are. As many of you know, hardware are going to be the physical components of your computer. So as I am recording these lectures, I am looking at my monitor or my screen. I'm using a keyboard and a mouse, in my case a trackpad, to interact and have input and output with the computer. Under the hood, there's a processor, which is a piece of hardware that is running the computer programs. And there's also RAM, or memory. And we have disk space as well. All hardware, right? Software are going to be the programs, computer programs that run on a computer. The one major piece of software that everyone who uses a computer uses is called an operating system. I'm doing this on a Mac, so my operating system is Mac OS 10, with X being 10. You probably also are familiar with Windows. We have Linux. We also have some other things called Unix. Tons of different operating systems that are out there. An operating system is basically a piece of software that allows the user to interact with it. Then you have other computer programs. As I type this, I'm typing in Microsoft Word. Word is a computer program, right? So that's all software. So now as we look into C and C++, we want to understand what is C++. Well, it's a programming language. We know that. It's based on another programming language called C. Let's say based on C. Okay? C was developed a long time ago. Actually, not all that long ago, but for some of you, it will seem like a long time ago. So C was language developed at, which is a place where a lot of early computer research went on. So it was developed in 1989. ANSI, the American National Standards Institute, is standardized in that year as well. And C was early on, it was used to actually program the computer programming language that we just talked about called Unix. So that's the programming language for Unix. Has a lot of what we call low-level capability. Basically means we are very close to the computer itself, closer to the hardware. That's what low-level means. Along the way, people kind of realized that maybe it would be easier if we had a higher level language. So there was a gentleman by the name of Bjorn Strustrup that added a bunch of extensions to the C language, thus creating C++. And the main thing that he did is he added this object-oriented programming ability or methodology. We'll talk more about that in a bit, but the big thing to realize from right now is that C++ came from C, so it's got thing that C has, plus more. All right. Now, when we talk about this C++, we need to understand that C++ is a, let's go to this next page here, compiled language. When you have a compiled language, you have 3 different basic steps that you're going to do. You have to enter your source code. You have to actually compile. And you have to link the program. When you enter your source code, this is when you're actually programming. You're putting in those statements. The compiler actually happens to be a computer program in and of itself. And what it does is it checks for syntax, or the rules of the language, just like we have rules for written languages and spoken languages, we have rules in computers, programming languages as well. So it basically goes, it checks, it's like the referee, it makes sure that everything's done correctly, and then it spits out what we call object code. The object code gets linked, and we get an executable. So in order to illustrate that, we can look at a diagram, and we will look at this diagram here, this diagram here. So as you can see, up here, this upper corner, the little gray box, that's source code. That's actually a working C++ program. So this int main, int ABC, char enter, all of that stuff, that text, that's our source code. We take that source code, we run it through the compiler. That compiler, if there's no errors, notice here, then we get object, an object file or object code. That object code then has to take libraries, which are basically pre-written code, that things that are useful that somebody else wrote, and it takes that and it links them. So there's actually another program called a linker that does that. It links the object code with the libraries. If there's no link errors, then you get an executable. When you get that executable, it will run on your computer. Down at the bottom, that software runs on your hardware, right? And you actually get output. So here we get please enter 2 numbers, 5, 6, the sum is 11, hit enter to exit. So we have a short program demonstration here. The thing to note here is the process. So the source code has to be compiled. Compiled generates an object file or object code that gets linked by the linker by bringing in the libraries, and then we get an executable. That's what a compiled program is, compiled language. There are other languages that are interpreted, which basically means that we kind of go straight to execution. But we're not doing in this class, we don't really cover those. Those of you that are in the programming concentration at CNM, maybe taking a Python class, Python would be one of those languages that is interpreted. So now that we kind of have an idea about general programming, hardware versus software, compiled language, let's talk about this object-oriented thing a little bit more and structured programming. So back in the good old days of programming, or in the old days, maybe not the good old days, programs followed a data flow. Written line by line, and it flowed from the top to the bottom, top-down programming. That's called structured or top-down programming. It's literally just a bunch of steps. So this is structured programming here. And we have object-oriented programming. So we'll call this structured. And here we're going to have object-oriented. The difference between the two is object-oriented is based on real-world things. So you look at it from a real-world point of view. Those Real world things are called objects. Okay, one thing to note, C++ is not automatically object oriented. Okay, you have to actually create objects. You need to understand for now that we have this capability in C++. In C++1, we actually will not be doing these things. We won't do object-oriented programming. That'll be saved for C++2. But just so you understand the history of things, we kind of let you know right up front that that's something that goes on here. Okay, so say we have an example, and if you look at the slides in that are accompanying the book, you'll see this example. So say we need to do this. We need to read data from a file, perform some sort of math on the data, and write the answers to a different file. To do this, we're going to create some job descriptions for our program. Okay? That's all done by using task class descriptions. Okay? After we've done that, we'll have a reader-writer job. So that just knows how to open the file, read from the files, write to the files. We'll have a calculator job. So that'll be the one that does the math, performs the math. Okay? Then we can actually have an object, a person, for instance, called Martha. Okay? So Martha's going to do this. She's going to open and read. She's going to pass data to Don. She's going to be able to do a bunch of different things. Don's going to wait and pass the data back. But if you look at this, it's actual objects, people. The people are the objects doing real things, okay? So they represent what happens in the real world. If we're looking at a structured example, let's look at an ATM, for instance. Someone goes to an ATM and they're dealing with it in a structured way. They're basically going to do this. It's sequential. They're going to insert their card. They're going to enter their PIN. They're going to put the PIN in the account number in. They get validated. Then they select cash. Then they enter dollar amount. Then their balance gets verified. Then their money is dispensed. Then they write a receipt. Then they return card. All sequential. Still works, but not quite as powerful as object-oriented. If we look at object-oriented, we have a number of different objects, or the class, the actual. So the class would be bank customer, ATM, and bank. They're not that they're the general types of things that we can create objects for. The actual object would be the particular type of bank customer, or name of our bank customer, who is Kelly, or we have a corner ATM. That's the name, and then we have a bank, right, which is the C++ bank. Kelly is able to do all of these different things. She can insert a card, she can enter a PIN, select cash withdrawal, enter amount, and so on and so forth. In C++, those are called functions, so she can do all of these different things with functions. Notice it's much more powerful to do things in this manner. So that's the difference between object-oriented and structured programming. Now, one of the other important things to look at here in C++ is you need to think things through. Don't just go and start programming. So one of the big things that we need to do is we need to have a way to organize things and think things through ahead of time. You can use something like this, which is a flow diagram, to think things through. So one way to do that is flow diagrams. Another way is just simply by paragraphs. For writing, what does it take in a simple to log for an ATM. Okay, so what does it take to read a card in? So what are the things that need to happen? Write the steps down. Step by step, paragraphs. And the last thing you can do is pseudocode. But if you remember back to our diagram earlier, we had some source code in here. Some plus code, right? There, right? Int min, int ABC. This C out here, it says please enter 2 numbers. So pseudocode could basically be enter numbers if numbers are between. Oh no, we're adding them. Oh, that's okay. We can do something else right here, right? So if numbers are between 1 and 5, tell user the numbers are valid. Else, tell user the numbers are invalid. What we're doing is we're using a combination of code and words to go ahead and let us know what's going on and to think things through before we actually start programming. So we got to make sure to do that too. So just some general kind of help for you guys up front. This was more of our introductory lecture. Next lecture, we'll start getting into some more of the specifics of the language. But if you have any questions, comments, or concerns, always email me. We have office hours, Tuesdays and Thursdays, or office hours on Tuesdays, lab time on Thursdays, so you can contact me there as well. And I look forward to talking to you soon. Take care. Bye.